I'm really delighted to be here. I have never been to South Africa before. It's my first time here. I am based in San Francisco, but I came here actually from a project that I did last week in New York City, where there was 4 feet of snow recently. So, yeah, if anyone needs to borrow a down parka, it's good to minus 15 degrees, let me know. But yeah, it's really nice to be in a little bit of warmer weather. This is me on the promenade down by the water on Monday, where it was way, way too hot. But look, I'm getting sunburned and I don't have to wear like fur-lined boots. This is so amazing. Sarah May, there's my Twitter handle. Twitter is mostly how I communicate with people. I'm very bad at email, although if you try really hard, you can find my email address. But good luck getting me to answer it. So if you want to get in touch with me, that's the way to do it. As Lance said, I'm one of the founders of RailsBridge. I did that back in 2009. I'm still on the board. I'm also one of the founders of Bridge Foundry, which is a thing we're doing now to bring the RailsBridge model to other technical communities. So there's Mobile Bridge, Closure Bridge, Go Bridge, and so forth. So that's pretty exciting. I'm also, as you said, a director of Ruby Central, so which means I work on RailsConf and RubyConf. This year I'm the program director for RailsConf. Tickets are now available. We just opened registration. You should definitely go get yourself a ticket and come see us at Kansas City. Most people know me by all of this nonprofit work that I do. However, most people may not realize, actually, that the nonprofit work isn't most of my job. I have a day job. And in my day job, I do software consulting with DevMind. I'm their chief consultant. That's my title. I even have business cards somewhere that say that on it. I always forget to bring them on trips, though. Which, you know, super useful to have a whole box of those at my house. So I want to be a bit clear about the type of consulting that I'm talking about when I say that I do software consulting, because people mean many different things when they say the word consulting. Most consultants work on projects. Company needs a thing built, consultants build a thing. Usually they're quite independent. They don't work at all with any developers that the client might have. They're kind of off on their own doing their own thing. That is not what I do. In the type of consulting that I do, I work on teams rather than projects. Usually teams in transition from one size to another, and I help them figure out how to navigate that. Usually means some combination of code changes, process changes, and I figure out what to recommend by getting involved. I basically move in. I go to their office, I pair program with their developers, I participate in their meetings, and I try to nudge them in the right direction. My goal is to turn them into a high-functioning team. Many people, I've discovered, have never been on a high-functioning team because they're disturbingly rare. A high-functioning team communicates well, and they're thoughtful, and they also get stuff done. And critically, they get the stuff done that matters. They build the right thing, and they know that the effort that they're putting into their code is going towards solving a real problem. The world needs more high-functioning teams. This is my personal crusade. Because after I graduated from college, I worked for almost 10 years in software before I was on my first high-functioning team. And when I started, I was like, so this is what software is supposed to feel like. This is awesome. Everyone on the team respected and trusted each other. We all had the same goals. And we were all moving towards them together as a unit. Everyone pulling together. We built some amazing things. And we solved some actual problems. And it was at that point in my career that I realized that I like programming, and I'm quite good at it, but programming itself is not what appeals to me about writing software. I'm motivated by writing useful code that helps actual people. I'm motivated by getting the stuff that matters done, and I'm not so motivated, as some people are, by the construction process, by programming itself. Now, in many ways, it would be easier for me if I were motivated by programming itself, because most software projects fail to produce anything of lasting value. Project is canceled, code base is shelved, company goes under. One study found that 68% of software projects in the US fail. 68%. That is more than 2 out of 3. And so if you're motivated by what software can do rather than by the construction process, it can be a tough world out there. And the truth is, we don't really know why so many projects fail. Projects fail despite our personal best efforts. despite 20 years of large-scale conversion to Agile, despite developer tools and languages that are constantly improving. Now, at a very basic level, projects fail because developers build the wrong thing. We're the ones with our hands on the keyboard. We build something too big and we never finish it. Or we waste time building features nobody wants. Sometimes there's nothing we can do. There's things we have control over and there's things we don't. But I think we have more control than we realize. Let me give you an example. One of the first projects when I got out of school, we were building a product on top of a document store. Now, in those days, this was the 90s, there was no MongoDB. Document stores were a very, very new thing. And an edict came down that said, must use document store, in a memo from the VP. Actually, I think his wording was, I think it would be a great fit for the project. I know what that means. So document stores, they're great at storing documents. We knew that what we had wasn't documents. And we knew that it would be an awkward fit at best, a disaster at worst. We worked our way up the chain to the VP, who basically said, I think it would be a good fit, several times in a row. So we thought, okay, well, maybe we can change what the product is so that it would better showcase this new technology that we've built. But we hit another wall with that because there was another VP involved in the project who was very invested in building this particular thing. So my boss sent the most experienced engineer on the team off to do the data store integration. A month later, it wasn't working. 2 months later, still not working. 3 months, still not working. 4 months, technically working, but way too slow. And the bottleneck was the data store itself. It was a brand new piece of technology, and it wasn't designed for the type of load that this product put on it. And shortly thereafter, the project was killed. And they did a big post-mortem on it, and the official reason recorded as why it was shelved is that the data store was too slow. But the real reason was a communication failure. Neither of those VPs wanted the project to fail, but they did ask for mutually incompatible things. And we, as the developers, were the only people who knew that. We were the only touch point. We were the ones that could have brought them together and tried to figure out how to salvage a project. But we didn't. And in the end, neither VP got what they wanted, and they were both promoted. And the thing is, I was really happy with the code I had written on that project. When I started, I walked into my office to find a copy of Code Complete by Steve Connell, which is actually still quite a good book. And the team valued well-factored code, good documentation. So I was really happy with the code that I wrote on that project, but I walked away from it feeling like a failure because all the work I had just done had been thrown away. And what I got out of that experience is a feeling like clean code is a really good thing. It's a good goal to have, it's a good thing to think about. Same with tested code. But neither of those is enough. To succeed in this new world of software, to build something actually useful, we need to widen our focus away from just the code and start looking at the actual hard problems in software. Because it turns out, software is people and only incidentally computers. So what are the hard problems of software? Let's have a look. Most of the teams I see have one or more of the following problems. The hiring problem. Why is it that if you hire a single asshole, the whole team falls apart? You know what I'm talking about. Why is turnover so expensive? Why is it that when one person quits, you can spend months recovering? Why is it that doubling the size of the team doesn't mean you get twice as much done? And finally, why is it that we have no good metrics that measure developer productivity? The hard problems of software, these questions cut right to the heart of why projects fail and why we can't predict them even when they succeed. All of these questions are about people. And our current models for software development aren't really equipped to answer them. Our current models for software development tell us that we are building a product. Our internal model for how we build software is oriented around products. And it's a holdover from the beginning of software, where maybe it was more like a product that you were finished with at some point. But there are many ways in which this idea and the words that we use around it no longer make sense. For example, we ship our code as if we were physically sending something away as it rolls off the assembly line. It's hard to call it shipping if you do it 10 times a day. We use the word maintenance as distinguished from development, as though our code were like a washing machine, and once it leaves the factory, nothing new is ever added, just existing functionality repaired. We think of producing software as though it were done in a factory, and this is our factory model for software development. And factory doesn't tell us very much about the people, about the workers. They're there, they do the same thing all day. Maybe they'll be replaced soon by robots, that's about it. And all of those hard problems, hiring, turnover, growth, productivity, the factory has nothing to say about those. Workers in a factory don't really collaborate, they don't communicate. So if you hire one asshole, it doesn't matter. He's still just there stamping his, the part to go on the thing, to do the other part, right? Like it's doing the same thing, he's not talking to people, it doesn't matter. Turnover is not expensive in a factory. Growth is not a problem. You build another assembly line, you can make twice as many things. And productivity, all you do is count the number of things that come off the end of the line. And in reality, how much of software is really like a physical product these days? Certainly not the web applications we build in the Ruby community. Most desktop software is web views. The ones that aren't auto-update themselves. Video games used to be more like products. A game would be completely finished, a team disbanded, but these days, even video games update themselves. Even video games are never done. So not only does the factory model fail to help us with our hard problems, but the words and concepts it gives us really don't even fit anymore. Now, it doesn't invalidate the model. We've used this model for 60 years successfully. It's built us some great stuff. Human brains are model-making machines, especially human brains belonging to developers. We build representations in our heads for how complex systems work. The quality of our internal model is what we call our understanding of the system, right? Our model is good the more it can both explain behavior that we see and predict behavior in the future in the real world. Now, some models are explicit, as in we see there's a system and we load it into our brains, right? Airflow turbulence models, complex software system at the new job. Other models are implicit, like our factory model for developing software. We don't really see it as a system so much as just the way it's done. It's the way things are. This is how we do things. But humans also have a grand tradition of turning their implicit models into explicit ones when the conditions change enough that it's time to do so. And that time has come for us. That time came for public health about 200 years ago, and I want to look at that transition and see how that helps us understand what's happening here. Until the late 1800s, across basically every culture on Earth, the model for how infectious diseases spread was called miasma. We call it now the miasma theory. Back then they didn't call it a theory, this is just how it works. And miasma literally means bad air. And this theory said that decomposing organic matter released poisonous particles into the air, particularly the night air, and breathing that bad air is what made people sick. So essentially it equated bad smells and night air with disease. Swamps in particular were thought to be unhealthy because of the miasma that they produced. This is an illustration from the 1830s showing cholera invading Europe as a poisonous vapor. Seems simplistic now, but it endured across different cultures for thousands of years because it does reasonably explain some of the things that we see infectious diseases do. For example, people in close proximity to one another often get the same disease. They're breathing the same air. Seems logical they'd be exposed to the same poisonous particles. Miasma also suggested actions to reduce disease, and those actions often worked. For example, the City of London built sewers and cleaned up garbage from the streets because they thought the bad smells were causing disease. What they actually did was remove sources of drinking water contamination. Another example, everyone closed their windows at night to keep the night air out because the night air was thought to be unhealthy. Closing the windows also keeps mosquitoes out. So the interesting thing was that this model was not fully correct, but it was nevertheless very useful. Louis Pasteur proposed a more correct model in 1861 called germ theory. which is mostly what we live with today. This says that disease is caused by microorganisms rather than particles, that may be present in a variety of different media, air, water, skin, blood, and so forth, and may be spread by different vectors, including airborne, but also ingestion, direct contact. And it was at that point, once we had the germ model, that the miasma model was organized and named in order to contrast the two. Now, this discovery is often presented to history students as a revolution. But the truth of the matter is that when Pasteur published his paper in 1861, very few people were surprised. Because as it turns out, in the years leading up to that publication, both scientists and the public could tell that miasma had difficulty explaining everything that they saw. They lacked a coherent alternative, but they could see that their model had problems. Sexually transmitted diseases, for one, not easily explained by miasma, nor is the fact that the previously unknown disease called cholera spread out to other areas along seaborne trade routes. So while there were a lot of things that miasma explained and it managed to do a lot of good in the world changed. Cholera, starting in 1817, is what changed it. Cholera presented a new set of problems that miasma struggled to explain, and ultimately led to the development of a more nuanced and complicated model. And that's where we are with software. We have a model we've used for 50 years. We've done some great things with it. It's still useful. But in the last 15 years, software has changed. The way we build it has changed. Even the nature of what we build has changed, and our model needs to change with it. George Box is the father of modern statistics, and he says, the most that can be expected from any model is that it supply a useful approximation to reality. All models are wrong. Some models are useful. Germ theory is wrong. There are many things it doesn't explain. For one, there appears to be a strongly genetic component to many diseases. There's a lot of things we don't understand about this yet. But adopting germ theory allowed the scientific community to make more progress than was possible with miasma. And so to make progress with software, we need a model that helps us solve our hard problems. It has to show us the human side of what we're doing. And there have been a couple of attempts at new models. One of them is the software craftsmanship movement, which is what I call the workshop. In the factory, our model for building software centers on the assembly line, where workers are interchangeable, likely to be replaced by robots at any time. In the workshop, our model for building software centers on a team of developers of different skill and experience levels, building a high-quality, one-of-a-kind product. It harkens back to the pre-industrial days when manufacturers like blacksmiths and glassblowers were trusted to do their job and not treated like replaceable resources. And the software craftsmanship movement sometimes take this very, very literally. Some companies even use master, journeyman, and apprentice as job titles, which feels a little bit like programming cosplay to me. The workshop model, however, does answer more of our hard problems than the factory model does. Let's run through them. Why can one hire collapse a team? Factory doesn't have any answers to that. The workshop, though, it's a small, tight-knit team. It makes sense. One bad hire upsets that balance. So they have a reasonable answer for this one. Why is turnover so expensive? Well, in the factory, it's not. But in a workshop, you spend years sometimes training someone from no knowledge to apprentice to journeyman to master. And if they leave in that time period, you lose all that investment, which is a pretty reasonable explanation. What the workshop doesn't help so much with is things like this. Why don't you get twice the output from twice the number of developers? If you build twice the number of forges, then you should be able to have twice the number of swords produced or something. I'm not entirely sure how that metaphor is supposed to work. It also doesn't help us much with this one. How do you measure developer productivity? The workshop, like the factory, sort of suggests that counting output somehow is how you measure productivity. It's the things you make that count. So the workshop isn't really a whole lot of help here. We're 2 out of 4, up from 0 out of 4 for the factory, so that's good, we're halfway there. The workshop model does some really interesting things. It pulls focus away from the product and puts it back on the people. But it is still fundamentally a manufacturing-based metaphor in which a thing is made, and that means it can't answer all of these questions for us. So the question is, is there something that can? Is there a model that's not manufacturing-based that we could consider? And that brings up a number of perhaps more existential questions, such as, what is software if it's not making something? What do we do if we don't build products? Who are we if we're not makers? I go to a lot of Ruby conferences. I go to quite a few other conferences as well. And one of the interesting things I've noticed meeting all these different developers over the last 5 or 6 years is that there are quite a few developers who are involved in or previously involved in the theater. Things like plays, live acting, musicals. There's a lot of other overlaps in our communities as well. For example, we have a lot of economists and we have a lot of musicians. But theater has always struck me as the odd one out. Economics is mathematical, music can be too. Theater, though, is a different beast. I suggest to you that we should think about software development like putting together a play. And I've been calling this the stage model. Now, I did some theater a long time ago in high school, which of course makes me an expert. So when I was thinking about this, I did a bunch of research. I interviewed a bunch of people that have done professional theater and have done software. And so let me explain a bit what I mean by putting together a play. When a theater production starts to come together, usually all they have at that point is a director and a script. They've decided what play they're going to do and who's going to run it, and that's it. And a script is just a skeleton. It's just dialogue. There are productions of Hamlet today in which the exact same words are said as a production 100 years ago and 200 years ago. The words stay the same. But the two productions will be dramatically different, though, even though the same words are said, and that's because it's the actors and how they decide to play the characters that make all the difference. The actors are the ones that put the flesh on the bones of that script. Just like a product person can have the bones of an idea, but it's the team that makes that idea real. Now, you probably all know that if you give two different software teams the same project and you make them work in isolation, they'll produce dramatically different solutions. Even if you give the same team the same project twice, for example, a rewrite, they'll come up with different solutions each time. Now, the same goes for a play. Even the same group of actors won't do the same production twice in a row because they're coming to it as different people than they did the first time, with different ideas. So once the director has selected some actors, they all get together in a room and they do read-throughs of the script. And this is where they all start figuring out how their character relates to the others. It's a combination of how they are personally imagining their character, the director's ideas, and how all of the other actors are imagining their characters. There's a lot of interplay. And people often change their minds about how they want to play their character based on the input and experiences they have in these initial read-throughs. Now, they may try a few different approaches to see which one works best in the mix. You can play Macbeth as an insane man, or you can play him as a sane man in an insane world. And depending on which tack you take, you end up with a very different production. So there's a lot of space in between the lines of dialogue in a play, and this is where the actors make those initial tentative decisions about what goes there. Not unlike how a software team adapts to different personalities. Maybe you're all full-stack developers, but there's that one person who knows SQL really well and really likes it, and the rest of you are just happy to let them have it. You adjust what you do and what you work on based on who else you're working with. And the capabilities of the team that you're on affect your solution. Maybe given the same web project, both teams would build a Rails app, but the team with some really great JavaScript people would gravitate toward a single-page web app, and the teams without JavaScript people would gravitate towards a more server-oriented solution. And finally, you might also adjust how you work based on who you're working with. Someone you're working with likes pair programming, so maybe you do a little bit of that. Or maybe they hate it, and you stop doing it. Maybe you're working in Johannesburg with someone in London who's 2 hours behind. You might adjust your work time to start and end later to have more overlap. The capabilities and interests and how they spend their time, how a team spends their time, depends on who is on the team. And it's the same with a play. So at this point, a number of things happen. First, the actors go off and do some work on their own. They memorize lines or they watch other people's performances. They do some reading. And at the same time, they're coming back together in groups and doing the rehearsals. Now, as they rehearse, the play grows more and more fully formed. The lighting and the costume and the sound and other folks get involved. And the actors start to solidify their ideas about their portrayal of their character. And at this point, it becomes harder or I guess at least less convenient, to rethink their original decisions about their character. If they did, it might require changes in other characters. It might require some costume changes. It might require some set changes. At this point, the team is being creative together. Oh my goodness, I'm sorry. I think it might just be a loose connection. Okay. So at this point, the team's being creative, they're changing things, they're gelling as a unit, they're finding their path. And it's not unlike the fact as you work more on an application, it becomes harder to rethink your choice of JavaScript framework, or it becomes harder to rethink your choice of Rails at all. At that point, you can make small corrections inside of these large decisions, but it's very difficult to back out and change those ones. And that's because in both of these cases, you're up against a deadline. For a theater troupe, it's opening night. For a software team, it's the launch date. A theater troupe is being creative, but they're practicing creativity on a deadline. On opening night, they're going to go out there on that stage and do something. It may be embarrassing the first few times, which is often why in the States, large theatrical productions start out in a secondary market like Chicago before moving to Broadway in New York. Much like your software team might launch a closed alpha to some friendly people who will give you good feedback. And if, like me, you have limited experience working behind the scenes at theater productions, you might think that once you get to the performance section, all the creative work is done. And at that point, it's just execution, right? We're going into maintenance mode. Well, it turns out, not quite. A play needs a live audience to be real. The actors play off the energy that the audience brings. And the same play will be quite different done for a matinee of school children than it will be for the next night for the Friday night crowd. And the actors also see how people react in general to their characters, and they adjust depending on what resonates with the audience. It's kind of like you launch a feature, and the way users use it, or don't use it, often surprises you. Good teams can take that usage information and that customer feedback and incorporate that back into their creative process, just like a good theater troupe can. So let's go back to the hard problems. Talk about what the stage can tell us about those. The hiring problem, in which one bad hire can ruin a team. In a troupe of actors, they depend on trust to get them through the bad takes into the good takes. If you read some of the science around creativity, what they've discovered is that you really have to go through the bad ideas to get to the good ones. So you can't just go directly to the good ones, generally speaking, especially in a collaborative process. You have to generate the bad ones, and then those lead you to the good ones once they're gone. And so if you're going to be creative, you have to be in what's called open mode as opposed to closed mode. Closed mode is more about execution. Open mode, you're relaxed and can make new connections between ideas. And this is especially important at the beginning of the process. But one thing we know about open mode is that judgment absolutely kills it. You need to be able to trust your coworkers on a high-functioning team. You need to trust them to be honest about their mistakes so that you can be honest about yours. And someone who's not able to communicate about mistakes without being judgmental upsets the whole setup and can poison an entire play or software team. Why is it that when one person quits, you can spend months recovering? Well, in a set of actors, swapping out an actor for a character halfway through rehearsals has huge ramifications. Everyone's already negotiated a set of roles, but here comes a new actor with new ideas about how that character should be played, and if it's a major character, it means everyone basically has to renegotiate everything. And it's the same on the software team. If you lose an engineer, even if you're able to hire for that position quickly, which good luck with that, you're never going to get that exact same skill set in someone else. Inevitably, they'll have different strengths and weaknesses, different blind spots, different interests. If the dev who did most of your SQL quits, maybe you have to take it on and hand off some of the Rails to someone else who perhaps previously was focusing on front end. So any personnel change causes a sea of mostly invisible renegotiation of roles within a team. And it can take a while to get back to stability. So why is it that doubling the size of the team doesn't mean you get twice as much done? Well, in a play, that's a bit like saying if you have twice as many people in the chorus, that means they can do twice as many songs, right? Having more people does give you a bit of slack. Perhaps you can have more understudies or something. But unless you fundamentally change the parameters of the play, which people do. If you get new people, then you're not going to really be able to make use of them. And their presence is a distraction. The director is being asked to find something to do for the idle actors. Maybe you could send them off to a little mini production of their own, like in a separate building or something. But basically, the way that the stage answers this question is it says, well, it's because the way that a project turns out is a function of the team that's building it. And if you change the size of that team, you're changing what you build, inevitably. And when you do that, you trigger all of these role renegotiations, and it takes a long time to get back to stability, just like it does with a single hire, but in a macro sense. So why aren't there any reliable metrics for productivity? Well, the stage actually helps us with this too. If you look at the word productivity, it is tied directly to the idea that there is a product. It's right there on the word. And like we said, originally productivity just meant you counted the number of products that rolled off the assembly line. And since the beginning of software, people have looked for an analogous number that indicates how useful a developer is to their team. But none of the metrics that we've proposed actually correlate. Not lines of code, not churn, not test-to-code ratio, not velocity, not bug count. None of them reliably tell you how useful a developer is to the team. Sometimes it's only after someone leaves that you realize how much they kept the team together, even if they weren't the most prolific coder. With actors, you have the same problem. It's very difficult to measure how useful an actor is to a production. There may be an actor with a minor part, but the way they work with other actors during the rehearsals and the suggestions they make can hugely affect the direction of a play overall. The difference between us and theater, though, is that theater isn't asking for metrics. They don't care. They don't think their value can be measured or that their job can be performed separate from other people, but we do. We think these things because our profession originated in hardware, which has a lot more constraints, and in the end game is a physical thing that gets shipped to a customer. Now, in reality, there is a value system for actors, and that is how much they get paid. But what you should take from that is that actors have a bullshit personal review system also, the same as we do. We are not hardware. Our end game is not a product any more than Friday night's production of Macbeth is a product. Our end game is an experience, and it's an interactive experience if you're doing it right, in which our customers tell us what they like and what they don't like, and we feed that back in to our next release. Software development on a high-functioning team is a creative process. That's the difference. You're making something. It should feel like you're all pulling together, like you're set on the same goal and like you're making progress. And we're the ones with our hands on the canvas. So we better make sure we're making the right thing. People are the center of software and not products. And using the stage as our model for software development instead of the factory or instead of the workshop puts people in the center instead of the products. The product is invisible. We all know what it is, but it's not the center of our process anymore. Now, we've known for a while that that's true. We've known for a while that software is a team sport, that empathy is a core skill for a programmer, and now we know why. It's because software, when done right, is a creative, collaborative activity. And the stage answers the hardest questions we have about software. We're breaking away from our industrial past, maybe, finally, forging a new path forward. Now, let me be clear. I'm not suggesting that you immediately adopt the tropes of the theater on your development team. The three models can all coexist. Remember, all models are wrong, but some models are useful, and each of these models is useful in a different way. They're useful for different things. The factory shows you what the rest of your company is doing, especially if you're in a large organization. At a certain scale, executives have to think of people as resources in order to just deal with the sheer numbers involved. And so understanding how that works is useful. By the way, the actual title of this photograph is Corporate Cliché Shot Number 57. And I was like, yes, that is what I want right there. The workshop shows us what happens when our hands are on the keyboard. It shows us how to work together as a team. It shows us what to do when we're trying to focus on the code. And that's useful. if not wide enough. But the stage shows us how we work together. It shows us how we relate to each other. It shows us how we keep joy and creativity in our work. And it shows us what a high-functioning team looks like. It shows us people, which are the hardest part of software. So take these ideas, use them on your teams, nudge them towards higher function. You can do this from the inside. We need more high-functioning teams. We need more successful projects. We need to build software that matters. We don't need more car-sharing services, and we don't need more ways for teenagers to send disappearing messages. We need software that works on the real problems we have, that works on violence and poverty and disease. And these are hard problems, and to solve them, we're going to need to be creative. And the way we enable that is by inverting our product-centric model to a people-centric one. Make stuff that matters. Break free of our industrial past. Make programming fun again. Thank you very much.